Ta-da-da. So we've reached to geometric progression 3.4. With this pace, I think I will finish the syllabus by next year, and that's impressive. Why? Because I was being told by my mom that you are so lazy, you are so not creep, you're lazy. Alright, that's the right term. I am pretty lazy, and by this pace we will finish it by 2021. No problem. If you have any questions in the meantime, please put them down in the comment sections and someone will answer them out, because I am too lazy, as you know. Alright, moving on to geometric progressions. What are geometric progressions? So now that you've learned what arithmetic progressions are, geometric progressions are something similar, but in this case what we usually do is we take the division of consecutive terms. In arithmetic progressions we took the difference of them. Now we are taking the division of consecutive terms. So a of n plus 1 by an is equal to r, and this should remain common for all the terms of the sequence, and if it is not common, then it is not a geometric progression. Very simple. Alright, now there's few remarks that you need to take care of. That is like the first term, the last term, they cannot be zeros. The division factor, the common factor, cannot be 0. Alright, now what do we have next is standard GP and its general term. So this is going to be a very fast paced thing. You'll only talk, I will only talk about, because I am the boss, I will only talk about the things which are really important for learning and from the exam point of view. Alright, so how do you define a GP? It is defined by AR square, AR to the power n, and the last term is written as AR to the power n minus 1. Where is it written in the book? I can't see it. I think, yeah, it's here. Now compare it with arithmetic progressions. How arithmetic progressions were written? They were written as A plus D, A plus 2D, A plus 3D, and similarly so on. So just compare this arithmetic progression and geometric progressions so that it is easy for you to remember how both of them are used. Alright, one more similarity here is, how do you write a general term for any geometric progression? It is same as you wrote it in arithmetic progressions. It is represented by t to the base n, subscript n. Alright, so if I've asked you to write third general term of geometric progression, it is going to be written as t subscript 3, and what would it be? A into r to the power 3 minus 1, which is ar square. Alright, I think that is easy for you to absorb. I am not teaching difficult concepts, and if they are difficult, probably you can move on to some other course. Oh, just kidding. Anyway, we move on to remark 6. What do they say? Keep this formula always in mind, and is known for the formula of nth term or general term of GP, with the first term a and common ratio r. Alright, which of the following sequences are GP? If a sequence is GP, then write the first term and the common ratio nth term. Alright, the terms are 2, 6, 18, 54. Now what do you have to do? You're quite intelligent. By now you know how to find the common term. You just have to divide the consecutive term a to the base n plus 1 by a to the base n. So in this case we will divide 6 by 2, then 18 by 6, then 54 by 18, and we'll check the common ratio. If it comes out to be correct, then it is called as a GP with a common ratio r. Alright, T2 by T1. T2 is a Punjabi word. I don't know why did this pop in up in my mind, but anyway, T2 by T1, 6 by 2, that's 3. T3 by T2 is 18 by 6, that's 3. T4 by T3, 54 by 18. Yalla habibi, everything is coming out to be 3. So that means this is a GP with the first term 2 and a common ratio of 3. Alright, now what we have is 1 by 8 minus 1 by 4, 1 by 2 minus 1. Alright, T2 by T1 is minus 1 by 4 by 1 by 8, that's minus 2. T3 by T2 is this by this, which is minus 2. Similarly, T4 by T3 is minus 2. So if you see, all of them are coming out to be with common ratio minus 2. Therefore this is a GP with the first term 1 by 8 and common ratio minus 2. Now moving on to the next one, root 2 by 3, 3 root 2, 6 by root 2, 12 by root 2. Alright, So you divide T2 by T1, it comes out to be 3, T3 by T2, it comes out to be 2. Oh, so the second common ratio is not coming out to be the same as first common ratio, so therefore this is not a GP. Alright. Now these are questions in the example form, not in the example form, these are questions for you to practice. Now you have to find the 10th term of GP, this, and you know how to find 10th term. AR to the power n minus 1, n is 10, so AR to the power 9, just put it that way and you'll find the term. A is 128, and yeah, that's it. 4th and 7th terms of GP are this and this, so you have 2 terms, you have 2 unknowns, then you can find the 2 terms from the 2 equations. Pretty simple, right? Try it on your own. If you don't get it, please let me know, we'll solve it together or someone will help you on the comment section. Now sum of n terms in a GP. What is a sum? What is the sum of n terms in a GP of a GP? Alright. How do you find it? They have given the deduction of it. If you want to know it, I can tell you, but it is not required because this is the exam of applied statistics. But anyway, S of n is given by sum of all the terms T1, T2, T3 till T of n. Then what they have done is they have written the general terms AR square, AR n minus 2, AR n minus 1, because the last term is n minus 1, as you already know. Now what they have done is they have done a trick here. And what trick have they done here is they have multiplied both sides with r. So this is multiplied with r, everything is multiplied with r, rsn, ar square, and what then they have done is 1 minus 2. Very smart of them, so that all of these get cancelled. Ar gets cancelled with ar square gets cancelled with ar square, and what you are remaining, what you are left with is a minus arn. Alright, and on this side Sn minus Rsn. So when you take Sn common, what is remained is 1 minus R. I don't know if I'm speaking wrong English, please correct me on that as well, but as of now we're studying about PGDAST. So anyway, so Sn comes out to be, you take a common here, 1 minus R to the power n by 1 minus R. Pretty simple. Now they have given 2 cases where the value of answer depends on the value of r, modulus value of r. Alright, you need not care about it. Even if you remember this one formula, that's more than enough. And even if you do not use different formulas, not a problem. Trust me on that. You can trust me on that. Alright, keep this formula always in mind, and is known for the formula for sum of first n terms of GP with first term a and common ratio r. So they keep the same remark every time, give the same remark every time. Alright, find the sum of GP with these terms 2, 4, 8, 16 and falana. So a is 2, d is T2 by T1, which is 2, n is 10 because they've already mentioned it. Now you put the values here, a is given to you, r is given to you, n is given to you, solve them and you get the value 2046. Wow, nice. Then you have to find the value of the sum of this GP. First term is known to you, then r is known to you. How do you calculate r? T2 by T1, and then you have number of terms, that is 8. Alright, if you put all those values, don't worry about those 2 formulas. As I said, it will take care of the answer on its own if you know a little bit of maths. And you're here with the final answer 1261 to 187. Now solve this question, and if you have any queries, if you have any issues, do let me know. Please share, subscribe, and if you liked it, please like the video, otherwise I'm going to come to your home and kill you. Till then, see you in the next video. Bye bye. Write down in the comment section, sorry there was a mumbo jumbo there. Bye bye, see you in the next one.